Section 6.2 is about adding and subtracting rational expressions. We're going to add and subtract rational expressions the same way we would add fractions. We just need to make sure that their denominators are the same. So in order to add fractions, we must have the same denominator. So what we need to do is we need to factor all numerators and denominators, divide out the complement factors. So basically it's saying simplify the fractions first. Then you need to multiply as needed to obtain the denominators with the LCD, which is the least common denominator. So let's take a look at 7/15 and 5/12. I can't simplify these factors anymore. Well, 15 factors into 3 times 5, and 12 factors into a 3 and 2 2's. So the smallest number divisible by 15 and 12 is going to have a 3, a 5, and 2 2's. So 3 times 5 times 2 times 2, that's going to be 15 times 2, which is 30 times 2, which is 60. And if you aren't certain how to find the least common denominator, let me know and I can point you towards some resources. So in order to make 15 look like 60, I need to multiply it by 4 over 4, because if I multiply by 4 over 4, I'm really harnessing the power of 1. And in order to make 12 look like 60, I need to multiply it by 5 over 5, again harnessing the power of 1. This is going to give me 28 60ths plus 25 60ths. 28 and 25 would give me 53 60ths. And 53 is a prime number, so I can't simplify this any further. So the answer would be 53 60ths. Now that's how it works with rational numbers. Let's take a look at some rational expressions. What's really nice is if they have the same denominator. If they have the same denominator, I just add the numerators and put them over the same denominator. So 3x plus y over 5 becomes 3y plus x. I add the numerators and I put them over the same denominator. 7 minus 11 over 7 and let me start over. 7 over 2r squared minus 11 over 2r squared gives me 7 minus 11 over 2r squared. 7 minus 11 is negative 4 over 2r squared. I can factor out a 2 from my denominator and my numerator, so I am left with negative 2 over r squared. It's important to remember to always simplify your fractions as much as possible. Okay, what we're going to do is we're going to add these fractions with the same denominators, and then we're going to factor them in order to simplify. So if I have m plus p over m squared minus p squared. Well, m squared minus p squared, this is a difference of perfect squares, so it's going to factor to m plus p times m minus p. See, this is why I told you to make sure you felt really solid with factoring, because we're going to keep using it for the rest of the semester. This is going to simplify to 1 over m minus p. Next, I'm going to go ahead and have 4 over x squared plus 2x minus 8 plus x over x squared plus 2x minus 8. So I have 4 plus x over x squared plus 2x minus 8. Now I need to factor my denominator. So I think, what are the factors of AC that add up to b? And the factors of AC that add up to b are going to be 4 and negative 2. I'm going to rewrite 4 plus x as x plus 4. As we see, this cancels, so I'm left with 1 over x minus 2. Next, I have 7x over 3x plus 1 minus x minus 2 over 3x plus 1. So I'm going to have 7x minus x minus 2. Note that I wrote it as minus x minus 2. That's going to help me remember to distribute that negative over 3x plus 1. That gives me 7x minus x plus 2 over 3x plus 1, which equals 6x plus 2. I can go ahead and pull out a factor of 2 in my numerator. So I have 2 over 3x plus 1 over 3x plus 1. Well, those 3x plus 1s are going to cancel, and I'm just left with 2.